Okay, so this one might be a little difficult to show on video, but you know that would never stop me from trying. So let me show you this, and then I'll draw a picture. Okay, so here I have a coil of wire. Here I have a magnet. And this is a galvanometer. And so basically this just measures the current, but measures very small currents. So let's, and what I did was, actually I'm not really positive, but I put a little piece of tape on this magnet, and I'm going to call that the North Pole. Might be wrong. So the first of all, it starts off like this with the magnet in the coil. And then I'll have to turn this on. So I push this button. And it says what happens. Okay, nothing happens if the magnet's in the coil. What happens if I pull the magnet out? Okay, you see I got a current. A positive current in this case. Okay, let me do it again. Positive current. Okay, now what would happen if I have two magnets together? So if you have two magnets with north poles together, they don't actually... I got them backwards. That one is wrong. I'm silly. Let's see if I can fix this real quick. Okay, just trust me. I'll take this off. Just trust me that they're both north poles are together. Do I get more magnetic field or less magnetic field? I get a greater magnetic field, but what about the flux? Okay, let's take that dumb thing off. I don't know why I even care. Okay, I'll just leave it. I say I leave it, and I'm still working on it. I almost got it. There we go. Okay, so they don't want to go together. I have to hold them like that. Okay, so I'm holding them together side by side. I'm going to put it in the coil, and then I'm going to pull it out quickly. And you'll notice that it went up to 10. It was a bigger magnetic field. Now, what if I put them so that I have north and then south next to each other? So I flip this one around. Now I do it. Barely anything, right? Because here I have a north. This makes a north magnetic field. So the magnetic field points. Actually, I have a little thing. That one makes a magnetic field like that. The other one makes a magnetic field like that. And when you add them together, you get a very small magnetic field. So small magnetic field, it doesn't matter. Okay, let's do this. Here's my coil again. What happens if I pull it out slowly? Can you see what I'm doing? Okay, now what happens if I pull it out fast? I get a little bit bigger current, right? The faster, it's not about the magnetic field, it's about the change in flux. Okay, so here is what we're going to do. Let's say I have this. I'm going to get rid of this whole thing. So let's say I have this is my magnetic field, and it's in the coil like that. So which way is the flux? Well, the flux is also this way. Now when I pull it out, the flux is going to decrease. I could keep the flux the same if the coil also made a magnetic field going that way. So if that was the case, what direction would the current be? So this wire wraps around that way. So if I put my hand in this direction, and I have the current going this way, that would make a magnetic field that way. So by pulling this out, I induce a current going that way. It's kind of hard to see with 3D stuff. Okay. Now, if I push the magnet in, now I'm increasing the flux this way, so the coil would want to make a magnetic field to oppose that going that way. And then that would make a magnetic field, a current going this way. Okay, I think I did a medium adequate job of explaining that one. But you're just going to have to practice.